Imagine a creature that can vanish in front of your eyes. 1 second it's perched on a rock, the next, the rock has eaten it. Its skin flushes from brown to ghost white to mottled coral in less than a heartbeat. And here's the twist that breaks your brain. This master of color is almost certainly colorblind. Meet the octopus, 8 arms, 3 hearts, blue blood, and no bones at all. It can pour its entire body through a gap the size of a coin. But its most jaw-dropping trick happens on the surface of its skin, which behaves less like skin and more like a living, programmable screen. To pull off the disappearing act, an octopus uses 3 different kinds of specialized cells, stacked in layers. Think of it like a tiny stage with paint, mirrors, and a spotlight. Each layer does one job, and together, in a fraction of a second, they recreate almost any background in the sea. The top layer holds the chromatophores, the paint. Each one is a microscopic sac filled with red, orange, yellow, brown, or black pigment. At rest, the sac is squeezed into a tiny dot you can barely see. But around it sits a ring of muscles, waiting for a signal. When the brain fires, those muscles yank the sac open like a tiny umbrella, spreading the pigment into a wide disk of color. Relax the muscles, and it snaps shut again. An octopus has millions of these, and it can pop them open or closed individually, painting patterns pixel by living pixel. Beneath the paint sit the iridophores, the mirrors. These cells contain stacks of ultra-thin reflective plates. They don't hold any pigment at all. Instead, they bend and bounce light, the same way a soap bubble or a peacock feather does, producing shimmering blues, greens, silvers, and golds that no pigment could ever make. And in the deepest layer are the leucophores, the spotlight. These are white cells that scatter every wavelength of light equally. They act like a blank canvas, bouncing back whatever color surrounds the octopus, and making the painted layers above them glow brighter and look richer. Paint, mirrors, and spotlight, all controlled directly by the nervous system. There's no waiting for chemicals to seep through the bloodstream, the way a chameleon's slower color change works. The octopus's brain talks straight to its skin muscles, which is why the transformation looks instant. Camouflage at the speed of thought. Now for the part scientists still find baffling. To copy a background so perfectly, you'd think the octopus must see color in stunning detail. But when we look inside its eyes, we find just one type of color receptor. By every normal rule of biology, a single receptor means colorblind, seeing the world in shades of brightness, not color. So how does a colorblind animal match colors it supposedly can't see? Honestly, scientists aren't sure yet. It's one of the ocean's great open mysteries. But there are some clever, hotly debated ideas, and they involve the octopus's strange, dumbbell-shaped pupil. One leading hypothesis goes like this. A lens bends different colors by slightly different amounts. Red focuses at one depth, blue at another. Most eyes fight this blur, but the octopus's wide, oddly shaped pupil might actually exploit it, focusing one color sharply at a time and reading depth as a clue to color. There's another tantalizing clue. The octopus's skin itself contains light-sensitive proteins, the same kind found in its eyes. So in a strange way, the skin may help see the light falling on it, sensing brightness directly without any signal from the brain. The animal might be tasting light through its whole body. Whatever the answer, the result is breathtaking. The mimic octopus can impersonate a sea snake, a lionfish, or a flatfish, changing not just color, but shape and movement. Others sculpt their skin into spikes and bumps to match coral or seaweed. This is disguised as a full-body performance. And the brain running this show is extraordinary. An octopus has around 500 million neurons, close to a dog. But here's the kicker. Most of them aren't in its head. Roughly 2/3 are spread out along its arms, so each arm can taste, touch, and even make decisions somewhat on its own. That intelligence shows. In labs, octopuses unscrew jars to reach food, solve mazes, and recognize individual human keepers, squirting the ones they dislike. Some carry coconut shells across the seafloor to use as portable shelters, one of the few clear examples of an invertebrate using tools. They escape sealed tanks, sneak into neighboring aquariums for a midnight snack, and remember the route back. Some researchers think octopuses may even experience something like curiosity and play, poking objects for no reward at all, simply to see what happens. Sound like anyone you know. So next time you picture an octopus, remember what you're really looking at. A soft-bodied genius wearing a screen for skin, painting itself into the scenery with paint, mirrors, and light guided by a brain scattered through 8 arms, solving a color puzzle it may not even be able to see. If this sparked a little wonder, you're exactly the kind of curious we're looking for. Subscribe to the Curious Owl for bite-sized wonder every single day, and we'll see you in the next one.